All right, today's lesson is graphing linear inequalities. Now, there's a couple of things you have to remember. First of all, we're going to be shading in because in inequalities there are infinite answers quite often. The infinite answers will be found in the different areas of the graph that you make. So, and the shading zone represents those right answers. Fine, relax. So now, a couple of things to remember. We're going to be graphing lines. The lines come in two varieties, either solid lines or dashed lines. If you have the less than or greater than by itself, that's going to be a dashed line. If you have less than equal to or greater than equal to, then it's going to be a solid line. Other than that, the words less than means you're shading below the line, and greater than means you're going to shade above the line. And that'll become more obvious when we start doing these examples. So if we start with example 1, here's what we have. Our inequality reads y is less than negative 1/2 x minus 1. So we have two boxes on the side, and we're asked to first describe would our line be solid or dotted. Because we have the less than arrow and it doesn't have a half equal sign, it's going to be a dotted graph. So we'll go ahead and select dotted to remind ourselves. And then when we do create the line, we're going to be shading at some point. We're either going to shade above or below. Well, the inequality reads less than. And less than implies that we will be shading below. Less than is below, greater than means above. So now we need to create a line, or at least get some points going. So what we're going to do is go back to Algebra 1, and since this is in slope-intercept form, we have our y-intercept given to us. Our y-intercept is negative 1. So on the y-axis, I'll go down to negative 1 and place a dot. Now, I need a minimum of 2 points to make a line. I can just follow the slope, negative 1/2, to get that line. So from my y-intercept, I go down 1, right 2, and there's my next point. For the sake of this explanation, I'm going to go ahead and fill in every other point along that slope so I can get the outline of my final line. So I'll go ahead and fill in every single point that fits on this graph with this inequality. Now, before I construct or connect the dots, I have to go back and review. Am I making a solid or dotted line? And we already established that it's going to be a dotted line. So the way I like to do it on these graphs is I like to just fill in the spaces with like a little hyphen, a little dash. So what we're creating is a border. All of our answers will either be above this borderline or below this borderline. However, none of our answers will be on the actual border. And I'll explain to you what I mean by answers also at the end of this question. So now we did our first part. We created our line. We made it dotted or dashed to show that it is just the border. And now it says shade below. And there's actually some nuances in the shading. You just don't color everything. You almost color everything, but here's the catch. Because with this line, our answers are not on this dashed line, here's how you're going to shade. You're going to want to shade everything underneath the line, but the way I do it is I don't touch the line. Do not make contact with the line. So what you want to demonstrate is that everything below this is an answer except the line itself. Think of the line almost like an electric fence. You can't actually be on it without it being something bad. So you don't want anything on the line, but you can take anything you want as close to the line as you can get without actually ever making contact. Now let me explain to you what this means mathematically. This means that I can take any point in that shaded zone and get its coordinates, get its x and get its y value. I can take those x and y values and put it into this original inequality expression. If I plug it in and solve it, I should get a true statement. Opposite of that is anything that's not in a shaded zone should give me a false statement. And that's what I'm going to show you right now. So do you agree that in this first example we just did, that the origin is not in the shaded zone? Do you agree that outside of the line? Yes. So that means that it is not an acceptable answer. And I'm going to explain to you right now what I mean by an acceptable answer. So the coordinates at the origin, everyone agrees, is 0, 0, correct? That means our x value is 0 and our y value is 0. So I'm going to go ahead and take that x and that y value of 0 and 0 and plug it in, substitute it in for the y and the x up here in my inequality. So here's what it would look like. It would be 0 is less than negative 1/2 times 0 minus 1. I'm going to simplify that using pen dots. So from left to right, here's what my statement says now. 0 is less than, what is negative 1/2 times 0? 0. And what's 0 minus 1? So true or false, 0 is smaller than negative 1. False. And think of a number line. 0 is right here, negative 1's over here. It's smaller. So 0 is not the smaller number. That means this statement is false. That means anything in this area is also not a good point, is a false point. Conversely, yes, sir. What is negative 1/2 times 0? What's 0 minus 1? That's fine. So I proved that anything that's not in the shaded zone is a bad point. Conversely, I can pick a point in the shaded zone and prove that it works. I'll take this point down here. Do you agree that that blue dot I just drew is in the shaded zone? So its coordinates are at 0, negative 10. So I'm going to check it and see how the x and the y react when I plug them into the inequality. The y value I have is a negative 10. So I have negative 10 is less than negative 1/2 times 0 minus 1. When I simplify this from left to right, I have negative 10 is less than, what's negative half times 0 again? Minus 1? Is it true that negative 10 is smaller than negative 1? Yes, that's why it's in the shaded zone. So any point in the shaded zone I would pick randomly would still make a true statement. Any point I pick in the unshaded zone will make a false statement. That's what that means by shading and not shading. So solutions are always in the shaded zone. Bad answers or false answers are outside of the shaded zone. Let's try another example now. Our next one is y is less than or equal to negative 2x plus 3. The inequality less than or equal to, will that be a solid line or a dashed line? Solid line. It tells you in your notes above. Less than or equal to, does that mean I'm shading above or below? Below. And we have our information that we need. We know that our y-intercept is at positive 3. So I'll make a dot right there. Now it says my slope is negative 2. Turn that into a fraction. Negative 2 over 1, which means from this y-intercept I go down 2, right 1. Down 2, right 1, and keep following that same pattern until I get every point that fits on this grid. And I can work it backwards to get the points that came before it. So I have all my points lined up. We already discussed that it's going to be a solid line. So I'll go ahead and connect all these points with a solid line. See how well I can get this on the screen without a ruler. Hey, not too bad. Throw some arrow tips. I forgot to do this on the first one. Make sure you throw arrow tips to show that this line does go infinitely in both directions. And then the difference between this one and the first one is that a solid line means any point on that line is also an answer. And as well as anything in which area am I going to shade? Below. So the way I show it up here is I start from the line and then start shading downwards to show that everything, even the line, has the right answers in this zone. Now let's say I'm still not sure if I shaded in the right zone. Maybe I have the zone wrong. Let's just pretend that I'm not sure. So I'm going to pick a test point to use. And my favorite test point to use is always the origin, because zeros are always easy math to deal with. So the origin is right here. The origin is in my shaded zone, correct? So if I plug in the x and the y, should I get a true or a false statement? If it's in the shaded zone, it should give me a true statement. So I'm going to use the coordinates 0, 0 from the origin to verify that when I plug it into my inequality up here, I get the right answer. So it would be y is less than or equal to negative 2 times 0 plus 3. I change the x and the y's to double zeros, like the origin is. And now simplify. From left to right, I have 0 on the left. What's negative 2 times 0? Plus 3. Is it a true or false statement that 0 is less than or equal to 3? Is 0 less than 3? Is 0 less than? But it could be or. And I'm glad you mentioned that, because some students think it has to be less than and equal. You can't be both, but you could be either one, and you're still good. So is 0 at least less than 3? Yes. And technically, if you pick a number on the line, you'll get that equals to 3 answer, which still makes it true. So anything on the line will give you an equal to 3. Anything below the line will give you less than and make it all true. So everything down here always works. I think a lot of you guys already know where this is going, so if you want to go ahead and get a jump start on the next two, they behave the exact same way. But I'm still going to explain anyways for those who just maybe need the verification they're doing it right. So go ahead and get a few seconds head start ahead of me really quick while I set up for the third one. You should have the skills already at this point. And remember, everyone at home is watching you guys, so no stress. Alright, so y is greater than or equal to 2/3 x minus 5. The greater than or equal to tells me I should have a solid line. And the greater than also means I'm going to be shading above, correct?
Yes.
Alright. My y-intercept is at -5. So I go to -5 on the y-axis and plot a point. My slope is positive 2/3. That's up 2 over 3. Up 2 over 3. Up 2 over 3. And I can follow it in reverse as well. I did describe it as being a solid line, so I need to connect all my points with a solid line. Let's see how well I can get that graphed on here. Arrow tips on both ends. And then I am shading above this line. Since it's solid, I start on the line and start shading above it. Now I'm going to pick a test point just to make sure I shaded the right zone. And once again, my friend, the origin is in my test zone. So if I plug in the origin's coordinates into my inequality, I should get a true statement. 0, 0 are the coordinates I'm going to use for my y and for my x. So 0 greater than or equal to 2/3 times 0 minus 5. If I simplify it, what's 2/3 times 0? 0 minus 5? True or false? 0 is greater than or equal to -5. True. 0 is bigger than every negative number. So I know I shaded in the right zone. I'll give you guys now about a minute to get a head start and or finish that fourth one. Pretty easy, pretty basic. Shouldn't be too much of a problem here. The greater than tells you what kind of line you're going to have, and it tells you where you're going to shade. -4 is your starting point on the y-axis, and your slope, like on number 2, as a fraction will be 2 over 1. Put all those components together and make your lovely darling graph. I'm going to change the color up to this teal that I like a lot. Alright, so greater than should be dotted line. Greater than means I'm shading above. -4 is my y-intercept. That's my starting point. 2 over 1 is my slope, up 2 over 1. Getting every point that I can to fit in. Now I will have a dashed line, so my answers are nowhere on this line this broken line that I'm creating. They're going to be either above or below. And apparently they're all going to be above this line. Let me go ahead and shade above the line, but not making contact with the line itself. Anyone have any questions about this? Did you guys get that? If you're still listening it on your own, you can work that out. Any questions or points of confusion? No, you're good? Tomorrow, we're going to extend this with 2 lines. And here's what the cool thing is. If you have highlighters especially. So tomorrow when we do 2 lines, let's say you do like a yellow and a blue, then the solution set turns out as green. If you use like red, and I think blue, you get purple. So just a heads up, if you want to do that tomorrow, you can. If not, you can still do it with a pencil. Now, while I have your attention still, let me go ahead and explain today's assignment, which unfortunately is not this, which is kind of fun. I like this actually. But it's related to what I was showing you with the test points. So if we go to today's assignment, you're going to have systems of inequalities. They give you a test point. So for this first one, we have the test point 1, 2, and they give us 2 systems. So for example, if I plug in the x as a 1 and the y as a 2, let's do that math. What would 6 times 1 be? Plus 2 is 8 less than 20. So that first inequality, 1, 2, is a true point. It works. How about the next one? X has to be less than or equal to 4. My x value is 1. Is 1 less than or equal to 4? Yeah. So I have 2 truths. Since they're both true, I hit yes and then submit. And I have been officially designated as awesome. So make sure you let everybody know that. I want it on my headstone whenever I die. And then you do the same thing over and over again. Your minimum amount of questions is 10. And once you get to an 80 or above, you're automatically boosted to 100 like always. All right, that's all I have for you guys today. If you have any questions, feel free to let me know. And those of you who were here for the recording, once I can get it to stop, we'll go ahead and stop it. There it is.